For f of x here, again, we want to make sure we find the boundary point. The boundary point where the absolute value is going to change the graph. So the boundary point is based on that inside piece here. And the boundary, when I solve for that, is going to be, well, I can solve this formally, but we can see that it's x is equal to -2. So that represents my boundary. Okay, this is my boundary. And when I want the positive version, okay, so in this case I'm going to do the positive version. My positive domain is going to be when it's bigger than -2. So when x is greater than -2. When it's greater than -2, the effect of the absolute value is not going to change anything because this is going to be positive, so we're not going to change anything. So the equation is going to be 3x plus 6 minus 2. Okay, and I can combine those terms, and this becomes 3x plus 4. When I want the other part, I want the negative version of this, is when x is less than -2. And when x is less than -2, the inside function is negative, so we need to change it to its opposite. So we end up with 3x minus 6 minus 2. That only the inside changes, and I can then simplify that to -3x minus 8. So writing this as a piecewise function, okay, we need to write the positive and negative domains. So it's going to be 3x plus 4 for the domain. It's going to be greater than -2, so -2 to infinity. And for the negative domain, it's going to be -3x minus 8 and the domain is going to be from -infinity to -2. Okay, so this represents my negative domain, this represents my positive domain, and I've written as a piecewise function using this curly bracket notation. So we want to graph this, so I want to find the vertex of this. The vertex is going to be where it bends, so at x equals -2, y is going to be equal to -2 as well. Okay, now if I'm not sure, I can make a table of values. I can make a table of values. I know it bends at -2. I plug it in, I get 0 for that. Remember that's why we had a vertex there, it's at 0. Y is equal to -2, so -2, -2. I can draw these parts of the graph based on the slopes and y-intercepts. Okay, it's got a slope of 3. It's going to have a y-intercept of 4. Okay, it's going to go like that. I can put some points in there. Okay, 0, 4. I can graph this. It's going to have a y-intercept that looks like -8, so down here, slope is going to be 3. So it's going to have a graph that looks like this. And I can put some coordinates in there. You know, I can put a coordinate of, I'll put a symmetrical coordinate there. That was -4, +4. Okay, and then that would mirror the y-intercept coordinate there. And you can use a table of values, you can use your slope y-intercept to graph that. But there's my graph as its positive piece and its negative piece.